Alright, hello. So today we're going to be tackling factoring complex and tricky trinomials. That happens when a is greater than 1, and then again c is the y-intercept. And we are going to be checking by expanding, and we're going to double check our work. So we're going to expand, we're going to double check our work, and I'm going to explain how we factor complex trinomials, or tricky trinomials, complex trinomials. It's where it's in any case a trinomial needs to be factored and a is greater than 1. So let's start. It's going to be factoring complex trinomials, and this is part 2 because I did a video on factoring simple trinomials as well. And let's begin. So factor and explain how to get answer. Show your work. So basically, we're gonna try and factor this trinomial. It has 2 in the front as a coefficient from a squared. So what we need is 2 factors that multiply to 2, or 2a to the power of 2. And then we need 2 factors that multiply to 2, this term. And then when checked by expanding, the middle term has to match. So it's a bit more complicated and one thing I love about factoring trinomials, whether they're simple or complex, is that you can always check by expanding to see if what you expand out matches the original expression that you were given. So, enough said, let's get to work. So with complex trinomials, we need 2 factors that multiply to the first term. That is the difference between simple trinomials and complex trinomials, is that we need 2 factors that multiply to the first term. Check by expanding always. You can do it most of the time whenever you need. I'm pretty thorough, so I always expand out and check. But let's begin. So, I'll zoom in here. We have our FOIL technique for when we're expanding out our factored expressions. So basically it looks sort of like shark fins, but it's called the FOIL technique. So we have firsts, we have outsides, we have insides, and then we have lasts. So we have firsts with blue, outsides with red, green for insides, and then lasts as well. I'll do that one more time. So we have firsts with blue, we have outsides with red, we have insides with green, and then we have outsides with orange. So essentially the FOIL technique is just teaching you how to expand out in a factored expression properly. And I color-coded them, and I sort of explained it's the first terms, the outsides terms, the inside terms, and then the last terms. So I'm going to zoom in, and then I'm going to zoom out. You might want to pause it here if you want to write this down. And then I'm going to zoom out. So, with complex trinomials, we need 2 factors that multiply to the first term, and that is the difference between simple trinomials and complex trinomials. So, blue is for multiplying to get the first term. Green is to multiply to get the last term. So that is color-coded there. And then we have a plus 5a in the middle. So we're going to have to see if it adds up to 5a. So I did 2a and 1a to get 2a and 1a to get 2a squared. And then I did 1 and 2 to get multiplied to 2. So what I did here is I got two factors that multiplied to 2a squared. And then I got two factors that multiplied to 2. And then I expanded out. So I did get 2a2, and then I got plus 4a, and then I got plus 1a, and I got plus 2. So that's what I got when I expanded out the expression. And then I simplified the addition between these two terms because they were like terms, combined like terms. And I got 2a squared plus 5a plus 2, which matches the original expression here. This expression is already done, so I just wanted to take you through a question that was already completed, and so you can see what goes on where. Alright, time to start. So we have set up our brackets. We need 2y and 1y. And then we have, so we need, so multiply to 2y squared, add to 9y, and then multiply to a positive 4. So, sometimes completing complex trinomials, sometimes it will be trial and error, and that's why I like expanding out, because you can see if it's correct or not. But what we need is, we need two factors that multiply to 2y2. We need two factors that multiply to positive 4. And when we expand out, we need it to match the addition and subtraction to match to positive 9y. So I have plus 1 and 4. So what we're going to do is we're going to expand out. 1, 2, 3, 4. So we have 2y squared and then we have 2y multiplied by 1i, that's 2y to the positive 2, or to the power of 2. And then we have plus 8y plus 1y, and then we have plus 4. And then we're going to take so we have 2y, simplify, 2y squared plus 9y plus 4. And that is our, so we factor And then we expand out. And then expanded expression matches original question given. Okay. And again, we need two terms, or let's say factors. We need two factors. And then we need to see if checked by expanding. With middle term. And then just to show you, and just to show you clearly, it's 2y plus 1, y plus 4. There you go. On to the next one. So we need two factors that multiply to 2a2. We need it to add up to 3a. And then we need two factors that multiply to positive 1. So we have, get our brackets ready, 2a, 1a, or just a. And then we need 1 and 1, plus, plus, and then we're going to check by expanding out. So we have first 2a2, sorry, I always do the equal sign, it's an arrow, 2a2, so those are the firsts, 2a multiplied by 1 plus 2a plus 1a plus 1, and then we're going to go down further, 2a squared plus 3a plus 1. And then we see that when we expand, it matches original question, expression or question. There you go. So, we have, we need two factors that multiply to 2x squared. It needs to match 2 plus 13x. And then it needs to multiply to positive 6. So, we get our brackets ready. We have 2x, and then we have x, then we have x. And we need it to multiply to 6, but to add to 13. So, I'm going to put 6 here and 1 there. So if you can see that 2x minus x, 2x multiplied by x is 2x squared. 2x multiplied by 6 is 12x. 1x multiplied 1 multiplied by x is another x, so it would be 13x, and then we have 1 multiplied by 6, which would be 6, and they're both addition, and then we're going to check by expanding. So we have 2x squared plus 12x plus 1x plus 6. And then we're going to simplify the middle term. So we have 2x squared. And then we have plus 13x plus 6. And then this matches original expression. And again, we need 2 factors that multiply to 2x to the power of 2. And then we need 2 factors that multiply to 6. And then like add or subtract 2 middle term. Moving on. So we need 2 factors that multiply to 2x squared. It needs to add to 11x, positive 11x, and it needs to multiply to positive 5. Positive 5 is a prime number, so it's just going to be 1 and 5. So we have 2x, x, and then I'm going to put 5 here because that would be 10, and 1, and it would be positive as well. So let's expand out. We have 2x to the power of 2. So we have blue firsts, outsides, insides, and lasts. So we have 2x to the power of 2. Then we have plus 10x. Then we have plus 1x and plus 5. And then we're going to move that down. We're going to simplify the addition within the middle term, within the middle of the expression. So it would be 2x squared. Then it would be plus 11x, simplifying the addition, plus 5. And it matches original expression. And now we have f. So we need 2 factors that multiply to 2k2. It must add to positive 7k, and it must multiply 2 factors to get to positive 3. Positive 3 is also a prime number, so it's just going to be 1 and 3. Get our brackets ready. K, 2k and k. And then we have, so it's positive 7k. So what I need, if I put a 3 here, that'll be 6. And if I put a 1 here, that'll be 7. And it's positive, plus signs everywhere. And let's see, so we have firsts, outsides, insides, and then lasts. So we have 2k to the power of 2. Then we have plus 6k. Then we have plus 1k. And plus 3. And then we simplify the addition in the middle. And then we have 2k squared plus 7k plus 3. And that matches original expression. And moving on. So that is all I have for us today with complex trinomials. We are going to go back and we're going to circle our answers or restate them. So we have 2a plus 1 and a plus 1, and we'll circle it. And then we have equals 2x plus 1, x plus 6, circle that. We have 2x plus 1, x plus 5, circle that. And then we have 2k plus 1 and k plus 3. So that's the, I'm going to star the answers. Okay, so I'm going to take you through the lesson one more time. We factored complex trinomials. We discussed that we needed 2 factors to multiply to the first term, and we needed 2 factors to multiply to the last term, and then we checked by expanding to make sure the middle term matches the original expression. We talked about the FOIL technique in terms of expanding out a factored expression to check our work and double check by expanding. Interesting. So we combined like terms a lot, and let's see. So we have our answer right here. Again, we have 2 factors that multiply to 2y2 that add to the middle term, multiply to plus 4 as well. And then we have this question, 2a to the power of 2 plus 3a plus 1. So here's the answer, and here's the answer. Here's the answer. There you go. Those were fully factored complex trinomials, and also fully factored and expanded out trinomials as well, just to double check our work to make sure it was correct. So thank you very much for watching, and I hope you found this helpful. Thank you.